In the last video, we talked about the situation where I'm taking 6 shots at a goal. We knew my probability of making any given shot, and what we wanted to do is figure out the probability distribution of me making k shots in general. We defined our random variable x as the number of shots I make out of 6. So I realized in that last example, and that example is right back here, that the math gets a little hairy. Right? You're dealing with 0.7 and times 0.3 to the fifth and all of that. So it got a little complicated, and what better thing to do if you have numbers like this, and even better than the calculator, than to use Excel. And you'll see that Excel is a fairly powerful tool for probability and statistics, and in general for a lot of types of simulations. If you don't want to actually write serious code, you can actually do fairly serious things with something as, you know, seemingly not so simple or not so serious as Excel, but it's actually quite serious. So let's see. So let's say that I'm going to take, let's define n. I'm going to say that I'm going to take 6 shots. The probability of me making any shot, I'll say, is 0.3. That's what we did in the last video. The probability of a miss, right? The probability of a miss. Let me actually write it a little bit more explicitly. Probability of a make is equal to 0.3, and the probability of a miss, I'm going to write, and instead of just writing 0.7 there, because we know it is, let's just make it a little bit dependent on the first one. So we'll write a formula, we'll say that's equal to 1 minus, and then we'll select this cell right here. It's equal to 1 minus the probability that I make a shot. And notice it just calculated it for us, 0.7. Let me zoom in a little bit. There you go. That might be easier for you to read, because I know it gets really small on YouTube. So, and this is neat, because now if we want to see what happens when this becomes 0.2, that automatically calculates to 0.8. So that's neat. Let's just put it back to 0.3. And now let's do a bunch of rows so that we can calculate the probability that, our random variable x could be 0 shots or 1 shot or whatever. So let's say that k, let me make a row called k. So that's the number of shots we need to make. So 0, 1, 2, 3, 4, 5, 6. You can't see the 6th one right now. Let me just go up here. And now you can see everything. That's the probability. And then we need to figure out the binomial coefficient. So that's well, actually, let's do it first. Let's say the probability of making any one of those, any one way of getting, no shots, or any one way of getting exactly 3 shots. So it's going to be the probability of a make. So you're going to make k shots times the probability of a miss. So if you make k shots, how many do you miss? You miss n minus k. And I'm not doing anything fancy in Excel right here. I'm just kind of writing a label that hopefully is a little intuitive for you. So this is the probability. This column is going to be like in this cell right here, is going to be the probability that any one particular way of making 3 shots and missing 3 shots. It's going to go into that cell eventually. And then you need the binomial coefficient. So you're going to need, it's going to look a little bit messy now, but it's going to be, so you want n, choose k. So essentially this row is going to say, what's the probability, for example, in this column, in this cell right here, we'll have the probability of making the first and missing the next 5, or missing the first 5 and making the last one. They're all going to be the same probability. You're going to have 1 make and 5 misses. And then this cell, we're going to say, well, how many different ways can I make just 1 out of 6? And that's why I'm going to choose 1 out of 6, right? K is 1 and n is 6. That's going to go there. And then we can calculate what the probability that our random variable is equal to k, is equal to this value. And I know it looks all fancy, but it's exactly what we did in the last video with my little doodle tool that I use, which is actually just Microsoft Paint, for those of you wondering, because I get a lot of emails and I'm tired of saying it's just Microsoft Paint. All right. So what's the probability that I make 0 and I miss 6, right? Because that's what they're saying here. So this is going to be the probability of me making a shot, and I'll put those dollar signs. That kind of fixes it on this cell. The probability that I make a shot to the kth power, right? So I make 0 shots times the probability that I miss a shot, put those dollar signs there so that it fixes on that cell, to the n minus k power, right? In this case, it would be the 6th power. I missed 6 shots. So to the, let me put in parentheses, n, let me fix on that cell, n minus k power. And there you go there. That's the probability, for example, of me making the first and missing the next 5. Or this could be the probability of me getting the first one, the first shot, then missing the second, and getting the last 4 missed. So any of one of those situations. And how many of those situations are there? Well, that's n choose k. So that's equal to n choose k. That's the same thing we did before. That's all this factorial stuff here. That's n choose k. So I'm just going to express the binomial coefficient expression in Excel. So it's the factorial of how many we're choosing from, how many shots we're taking, and the Excel function for that is fact. So we'll take the factorial of 6 and we'll divide it by, I'll put a parenthesis here, the factorial of k, right, times the factorial of n, let me fix that, n minus k. I know it fell off. Let me, n minus k. You put some parentheses there, so parentheses match up. And actually this just what fixes on this cell. Let me put an F4 there. And then there you go. There's only one way to choose 0 things out of 6 things, right? That's what that tells us. And then the probability that my random variable is equal to k, or in this case that I make exactly 0 shots, is equal to the probability of any of the specific ways of making 0 shots times the number of those ways there are, times that. So that's the probability of making 0 shots. And this is the cool thing about Excel. We can now select these cells and just go into this right-hand corner and just drag it down, and it'll do that calculation for all of them. And this is neat, because it calculated the binomial coefficients, right? This is 6 choose 3, right? N is 6, k is 3. This is 6 choose 3 is 20. It's nice and symmetric like you would expect. But the probabilities aren't that symmetric because, you know, we have 0.3 and 0.7. So it's not like the flipping a coin example that was 0.5 on either side. And oh, sorry, these aren't symmetric. And then when you multiply these, of course, these don't look symmetric. But it's hard to look at these numbers. So actually, let's just use the powers of Excel to graph this probability distribution. So let's say insert chart. And I'm clumsy at inserting charts. So let me see. The data, I think this is how I do it. I select the data. There you go. And then I need to select the label, the category X labels. Okay, that's going to be that right there. And then, let's see, next. That looks good. That looks good. I don't want to have anything. I don't need a legend. I don't want to show a legend. There you go. All right. Now I think I am finished. Right, data labels. Yeah, that's fine. Okay, finished. I don't want to get too fancy and there with the letters all big. Let me make this bigger for you. So this is neat, and I wish they didn't make the font so big, but you get the point. This is a discrete probability distribution of me making, in this case, k shots out of 6, right? And this was based on the fact that my probability of making any given shot was 0.3. And let me see if it'll actually, and I'm not making any promises here, let me see if I can actually make it so that it changes. See, if I make it 0.2, does it change? Oh, it changed. Look at that. That was neat. Let me bring this up a little bit. So what was neat is, so if I have a 30% chance of making a free throw, that is my probability distribution, my discrete probability distribution of making k shots, right? This is my probability of making no shots. I think it was like roughly, oh, it even gives us, it tells us it's 0.12%, or it's 12% chance of making no shots. My probability of making 4 shots is only 6%. I know you can't see it, but that little window that shows up right under my pointer says 0.06. So this is neat. And since the way we set it up, we can actually change it so that if I have a higher probability of making a shot, now it looks pretty symmetric. Now my chances of making 4 shots is the same as my chances of making 2 shots. And if I'm really good at making baskets, then I have an 80% probability of making any given shot. Now all of a sudden the whole distribution has shifted to the right. But I just wanted to show you, one, this is I think a pretty neat way to use Excel, and hopefully it's not too daunting. And the other thing is, these are all examples of binomial distributions, and I wanted to give you an example that might be a little bit more relevant to your everyday life. And it actually is the probabilities of making and missing aren't the same. They change. If they are the same, then you end up with a situation like that. Let's say you're a horrible basketball player and you only have a 10% chance of making any given shot. So there's a very high probability that you make no shots. Let's see. There's a 53% chance you make no shots, and then there's a 35% chance you make one shot, and so forth and so on. But this is pretty neat. This by itself is kind of a fun little toy, and hopefully you have enough information to do it yourself, or maybe experiment with more. What happens if you have more than n? What n goes to? Actually, maybe I'll do that in the next video. Anyway, see you soon.